I'm Travis Krebs.
I'm Logan Kenner.
I'm Zane Smith.
Today we're here to talk to you guys about our Gearless Transmission. So basically this all started in Morgan's physical science class. We were like non-conventional students, so we were doing anything we could basically to like distract him from doing actual classworks in physics. So one day he started talking about how he was wiring up his son's power wheels, and we just took off with that, and like we tried to distract him all day long, just by talking about his Gearless Transmission and giving him new ideas or whatever for what he could do with his power wheels. And he just made us a deal, and it was like, if we could make our ideas into a real life thing, then we didn't have to do anything for the rest of the year. And it turned into this big old thing. So our main objective for the entire thing was we just wanted to create a power wheels with 3 speeds, a 6, a 12, and a 24 volt, and it wanted to have forward and reverse. Later on, we also decided that we wanted to have regenerative braking. You want to be standing in front.
The type of switches we were using for this project are called double pole, double throw switches. And as you can see, on the right here is a picture of the switches. On the bottom of them, you have 6 metal tabs, which you can solder wires to go to whatever you were using the switch for. And on the left is the diagram for the switches. And these 2 middle levers are like, whenever you throw the switch, it'll either go to here to connect, which the power will go through, or it'll go to over here. So the power will go to like a different circuit that you have on.
Basically, these are just like 2 light switches put together. So like a normal light switch would just be this right here, like one way would be on, the other one would be off. Instead of like 1 bar, like doing the current, it's just 2 on the inside. And the only reason we did that is so it gave us like more tabs to connect wires to.
This is a little bit on series and parallel. On the left, you have a series circuit, and on the right, you have a parallel circuit. In the series circuit, these little squiggly lines right here are called resistors. And these lines, like up and down, horizontal, is a battery. So whenever the power goes through the resistors, it limits it, like, it'll be like 12 volts going here, but each one, I can't remember.
Okay, so basically in series, like the resistors will absorb some of the energy as they go through it. So let's just say this was a 12 volt battery and we only have 2 resistors. Each one of these are only getting 6 volts of power. So it like absorbs energy as it goes through. In parallel, instead of it like absorbing energy as it goes through, it splits it to both of them. So like if this was a 12 volt battery, both of these are getting 12 volts instead of splitting it like this one.
So this is our first diagram that we made, like our first model. This would be the first battery and the second battery. This was for like the reverse and forward. And then these right here are the 2 motors, and one was like a passenger side motor and the other was a driver side motor. This is just another drawing of it where we like gave examples of like low, low, high, low, and like high, high. And nothing really changed in this one. This was just like a different drawing, more detailed.
Yeah, this was just a more detailed version of like the previous one. In this one we were just trying to figure out like how many gears we could actually have with like the amount of switches that we wanted to put in there. So this we were just figuring out like kinks with it.
This is our first horizontal diagram, and we also drew this on the board because like we were going through a bunch of different designs at the time. This right here is a button, which is just like our relays and stuff. So I think this one would be like the button to go forward, and this one would be the one to brake. And these are the magnets that actually work with the relays.
So you guys might wonder like why we switched it from being horizontal to like, or from vertical to horizontal. And the only reason is like in your car we wanted them to be on the diagram how they would be in your car. So in your car you're not going to have switches vertically. Most of the time they'd be like horizontal. So we just wanted it to be like on the diagram how it would be in the car.
This is just us soldering the wires to the switches and like the tabs on the switches. I think, isn't that yours?
So basically we decided to put in relays whenever we wanted to do regenerative braking. The only reason we put this in is because this like controls a bunch of power with like a little bit. So this just like closes a circuit, like on the inside of this. So like I said, going into regenerative braking, whenever you're driving down the road or whatever, we wanted it so at the power wheels, whenever you let off the gas in the normal power wheels, it instantly will slow your car down because the motors like aren't being gave power to like continue going. So the relays made it so instead of the motor stopping, it gave you like it let you coast forward in the like when you close those relays down or whatever, it short circuits the motors, making it so like they can't coast, like they slow down, and it also sends all the power that they're still making when you're not giving it like power back to the batteries. It's like if you're coasting down a hill in it or whatever, and you're holding the brake, it short circuits that like the circuit, sending the power that the motors are making back to the batteries.
This is our first computer-made diagram. This one's still like a vertical one, but like this was the first one that we actually started color coding, because whenever we started wiring it, we realized that like just all these wires everywhere it's so messy. We don't even know where it leads to. And so these right here are relays. Like this is the clamp part and this is the magnet part that actually controls the clamp. This is a button, that's a button. This right here is a fuse. So whenever it gets overloaded, it shorts the fuse and doesn't short the system. This is one of our final diagrams, and this one is completely color-coded, horizontal. Here's our two motors. These are our batteries. This would be our battery switch, our forward and reverse switch, and then our motor switch.
So basically the difference between like these two is, whenever we did all this, we would go on the chalkboard, we'd put all our ideas down on chalk, and then we would go like to paper diagrams, and until we had it perfect on paper, we wouldn't even go onto the computer. So like we went all the way from like the chalkboard to paper diagrams, like being on the computer a few times, and then we started color coding it, and then like we did all of this for the vertical diagram before we even thought about like going back and doing it horizontal. So that's just saying like how many times it really took for us to like figure out how this thing works. We did like 20 of these diagrams before we even got to the horizontal ones. This is just showing like how we wired the batteries up to get like series and parallel, which we'll explain more later. So this is basically just a diagram to show you guys like how we made the different speeds. Like we were saying earlier with series and parallel, series will like split your voltage in half between the motors, but parallel gives it to them like the same. So let's just say you have both your switches in the high position, which is like up. Your batteries would be in series, which are like, it's putting out the maximum amount of power. So like we had two 12-volt batteries, and they're giving out the maximum amount, like 12 volts, so it'd be 24. And then with the motors, they were in parallel, so instead of like each motor getting 12 volts, like half of it, they're both getting the full like 24. And then for like the series, or for like the middle gear, which would be 12 volts, you put the batteries in like a series position, so it's putting out the full 24 volts, like the same as the high gear, but instead this time, like each of them getting 24, instead of like each of them getting 24 volts, you split it this time. So like instead of it going to both motors at the same time, now it's going to like one after the other. And then you could flip the switches like either way to get the 12 volts, but the only difference is for this one, it's not putting out the full amount of juice that it was before. Like series, this was putting out 24 volts, not 12. This one's only giving out 12. But instead of splitting it, instead of splitting the 24, like we did in this one's like distributing it evenly to them. So like this is only putting out 12, and it's giving 12 to them. This is putting out 24, but it's only giving 12 to them. Then for this one, it's in parallel. That means that it's only giving out the 12 volts or whatever, like half of its capacity, but it's splitting that 12 volts between the two motors. So it's like absorbing power as it goes through it. That's how we got the 3 different gears.
So this is our terminal block. At first we were using wire nuts, which just you put the 2 wires in and you twist them so they're like connected, and that was a giant mess. And this still looks like a giant mess, but in reality that's more organized than what it actually was. This is a diagram that I made to like organize all of it, so that way we know where each wire is and where it leads to. So like this would be motor passenger negative, so like the negative wire for the passenger motor. And then if we ever wanted to add something in, we could just throw it in, or if we wanted to figure out what's wrong, we know exactly where it's at, instead of having a jumbled mess of wires everywhere.
Yeah, we basically made this so if we ever wanted to like recreate this, we gave each like section of the block its own like specific thing that it does. So we kept running into problems, and we would have to go through the entire circuit every time and like take the entire thing apart and like test the wires to see where the connection stopped. For this one, if like, let's just say the passenger motor didn't work or whatever, we could go exactly to that block, test those wires, and like see what was wrong with it. So it's just an easier way for us to like double check if stuff went wrong or to like recreate it.
This is our final diagram that we made. Right now it would be in high, and everything's listed out here. We also listed the colors of each wire for if we print it out in black and white. That would be high, low, and then the other one would be low, low.
This was the reverse one. I never explained to you guys like how we got reversed, but it's super easy. So basically this switch right here just sends the power.
It looks super
through-
easy now, right?
Yeah, but all it does is it sends power through everything the opposite direction. So it would just spin those motors the opposite way. So that's the worst. And this is just a video of like us using it.
Is that Cadillac?
Yeah, it is.
Yeah.
So that's the low here, that's the medium here, and that's the high.
That's
Or no, that's the second medium.
And then that's the high.
Yeah.
And then that's the brakes.
All right, thank you very much, Sam.